for the day and doing an excellent job. Thank you, Danielle. So hi, Flynn. Thank you for
Hi
joining
there.
us again. It's always such a pleasure to see you. Um,
Thanks for having me again,
yeah, and you're sharing the stage with Christopher today. This is
which is going to be
exciting.
awesome.
I'm actually really excited for this talk. When Catherine first proposed it, I'm like, this could be really cool. So we're gonna step out, let you all introduce each other, and we'll try to stay on schedule. Thank you.
Hi, hello everyone. Can you hear my interpreter right now? I just want to make sure. Great. Okay, they can hear us. Great. Whew. Technical problem subsided. So I wanted to start. Do you mind if I share my screen? I want to make sure. I don't know if you guys can see my screen right now for the presentation. It's asking me, the interpreter. I cannot see the screen. No. Flynn, do you see the shared screen like previous?
So I have just shared that, and I believe that now everybody can see it.
Yes, an interpreter here. I can see the screen. You're good to go.
Excellent.
Great.
Okay.
All right. Yeah, thanks for the technical problem, Flynn. Okay, so this is a little different. I do have the screen up, but just so you know, it'll be might be a little choppy at first because I have my screen here and me here. I am Chris. I'm the tech lead and data scientist at Booz Allen. I'm also a disability and neurodiversity here at Booz Allen, and I'm a member of the Deaf CNCF work group here. Flynn, please go ahead and introduce yourself.
I am a technical evangelist for Linkerd at Buoyant. This is actually my inaugural time on stage as a co-lead of the newly formed working group for AI gateways within the CNCF. So that'll be interesting. I am also involved with Merge Forward and all of this stuff. It is wonderful to share the stage with Chris. It's going to be a lot of fun seeing how this all goes. And with that, I'm going to hand it back to Chris so that he can talk about what we're doing here.
Thank you, Flynn. And also, I wanted to say, yes, it's also my first time presenting here at KubeCrash. And, we'll get some room to breathe here. But again, yes, we're going to be talking about the AI ML black box, what observability means exactly, and why it's important for AI. What exactly Linkerd is, and why that's also important for AI. So I'll discuss that a little more later. We also will have a demonstration today by our MVP Flynn. So hopefully that demonstration goes well and we have no problems come up with that. Okay, so next. Yeah, fingers crossed, right, Flynn? Fingers crossed. So most of you know the AI ML black box, they do get trained and those models also get queried later. The models actually get trained on tons of different platforms. I'm talking about like Google Cloud, AWS, Azure, and also the training, for example, we tend to talk about using the Databricks and making your own notebook, some kinds of things like that that'll happen inside and outside training with Kubernetes. When it's ready to be sent out there, we notice that the queries actually increase from the microservers inside Kubernetes. Go ahead, you can do the next slide. So understanding that both these parts are equally important and understanding that computationally, this can get expensive and we don't want to waste anything. We don't want anything to go wrong. And we want to know that when things go well on our end, as well as on the user's end. And we can talk about the different perspectives, the different tools, the observability tools, the gauges, and all the different dashboards and things that are involved. And I'm going to show you that here and in the demo. You can go ahead. So, okay, just a quick snapshot here. I'm not going to go too deep into this part, but why X-ray vision matters for AI? Why is it important? It's above and beyond just when things happen, what happens. A lot of times these are silent failures that we don't notice. Using Linkerd, why that's important is we can actually spot and notice things like model degradation and when things slow down early before they impact users and before they even notice it. We have true observability, which means that we have the full view and observability of the client's requests, the successes and failures, and when they fail and why. Go ahead. So again, I'm not going to talk about this part too much. We're familiar with this, but really quick, observability. I'm going to take this quote from the Linkerd dictionary. Understanding that it's the system health and performance from the data that it generates. And then monitoring, mostly using this application at that server level. We also use service meshes. We're going to talk about the meshes a little bit later and how we use those next. Go ahead. So Linkerd itself, a service mesh, can actually provide that infrastructure. And that infrastructure can add security, observability, and real-time reliability. And we can actually intercept those network communications to mediate and measure everything that's happening on the network. And we also get the automatic metrics and observability and more. Go ahead. So Linkerd actually captures what we call the golden metrics. These are latency, success and fail rates, and traffic rates. And we can actually use this as an observability tool, or through the dashboard, we can actually see that for the graphs, what services are being used, and also following any of those requests through the process for failures and successes to learn better about what happened and in real time. Go ahead. So typically, with these server meshes and the services inside, when you have this application only, you'll often basically depend on the service logs and the high level infrastructure metrics. Again, using CPU, the usage, the pod health. And we can actually notice that these things are slow, they're manual, and sometimes that they're not fully complete. And if there's failures, that takes longer. It doesn't really give us a full view of everything that's going on that we could actually use. Go ahead. So the golden metrics here show us the full visibility. It shows us the graphs, the pictures, everything we need to see in actual real time. What's happening, where the breakdowns and slowdowns are, and not just that a request failed, but it gives us the idea and information on why it failed. Go ahead. So the point is that observability is essential. It's important. It's not just an option anymore. And I don't mean, the concept. Noticing that everywhere people say we need to have observability, we need to have that insight. How do we get that for the models? The preventions and the issues coming up, we can notice those before they hit the client. Go ahead. So I wanted to go through these three layers just simply. The first layer, I'm talking about the network at Linkerd. We have the automatic metrics. Those are in real time again. It's zero config. It means that we don't have to worry about making changes to the code to use the application itself. And this is actually less worry for the developers themselves. Go ahead. Layer 2 is the application itself. As I mentioned before, it really does depend on those service logs for the application itself running. So we look at the model, we notice the degradation, the prediction confidence, and sometimes we, realize that the AI model itself needs more data training. And sometimes the model itself later on needs to be retrained again. And this is an internal model for training. Go ahead. So for layer 3, this is tracing. We're using the network data with Linkerd, and we can actually have the full end-to-end visibility to follow the tracing and to see from the client side through the model, through the service meshes, using that model to the end and back to the user. We can integrate this with the application And Flynn is going to talk about this a little more later and during the demo. Go ahead. So now the demo itself, I know I've been blabbing on a little bit, but I'm going to have Flynn demo this part soon. But we're using K3D. Now, this is a lightweight Kubernetes cluster. It's on our machine here locally. Obviously, we'll be using here a laptop. We do not use a GPU. So for that reason, we're going to stay with a small toy model. We did do some testing. We injected errors and played with this to make sure that the AI toy model worked. As well as Linkerd uses the golden metrics capturing, as I said before. Go ahead and continue. So again, with Linkerd, as Flynn is going to demonstrate, we do have some kind of slow responses or if there's user errors. And before this impacts the users, we can use this to improve that. And I hope you like the illustration on the slide. I did that myself. Continue. Okay, so I'm going to pass this over to Flynn now and let Flynn take over the show and do his thing. I'm excited to watch this demo with the rest of you.
So let me talk a little bit about how we put the demo together. After catching the tail end of that panel, I feel like I'm starting out by enabling people to do shadow AI now. So sorry about that. The idea here is that we wanted to do something where we could demonstrate actually running AI models to do inference with everything running locally on a laptop, specifically my laptop. This is a 14-inch M1 Pro MacBook Pro from a few years ago that is presently running K3D and the Ollama models and the Ring Central UI. And and it all works, which is, or at least it did when I tried it earlier. So everybody keep your fingers crossed. What we have here is a pretty standard model. We've got a client outside of our cluster talking through an Ingress controller to the models. It's a little bit more involved with that. We actually have another pod in there acting as our application. So we've got the usual layered model where you've got the client and the Ingress controller in the application and some backend stuff deeper down in the call graph. We deliberately kept all of this very lightweight. So the AI Ingress thing that I'm showing here, the AI app thing that I'm showing here, we are not running full-fledged inference routers or anything like that. These are very, very simple Go programs. Because again, we're doing all of this on a laptop and we want to keep things light enough that the models actually run. We also have things set up here. So of course, if the model returns an error, that will be propagated all the way back. But the app itself has the ability to inject errors also. Mostly what's going on here is a lot of what we're talking about is detecting things going wrong and trying to figure out, using observability, where are they going wrong? What exactly is going wrong? So being able to inject errors makes it a lot easier to practice using these tools. The Ingress and the app and the models are all meshed with Linkerd, and that permits all of those Linkerd proxies to collect the golden metrics, feed them back into the Linkerd visualization extension, Linkerd Viz, and we will use that to watch what's going on. So what we're trying to do here is validate that everything works under normal conditions, test what we can see about faults, and see what we can see when things are going wrong. The point is to let you be able to see what's going on in real time. And if you set this up correctly, you can be able to tell if problems are happening before your end users start complaining, or at least before they start complaining a lot. You need to be able to catch things in time to do something about it. So everybody cross your fingers. It's always fun doing these things. In the interest of time, I don't remember exactly how much time we have left right now, but in the interest of time, we already have the cluster set up. So it's been running this whole time. We have some namespaces here, obviously. In the Ollama namespace, we have 3 replicas running Ollama models. They are presently sharing all of the same models. There's no real distinction between the 3 of them. I'm kind of looking forward to going and playing around with that. Okay, so I am told that we have 10 minutes. I think we'll be okay. In our AI app namespace, we have our little application itself. We've got the AI app deployment in the AI app namespace. That is our application. It's not a very sophisticated application. It will accept queries coming in from the outside world, and it will forward them through to Ollama. It also has some ability to both inject errors and control Ollama. So when we publish the source code, as you go through and play with it, then you'll be able to do things like dynamically change the error injection and load models and things like that. We also have the AI Ingress deployment sitting out, acting as our Ingress controller. Again, very simple proxy. It almost literally takes everything coming in and just immediately forwards it over to the AI app. It does also respond to Kubernetes liveness and readiness probes because you need that for Kubernetes. The point here is we're trying to show observability on a laptop. We are not trying to show full-fledged semantic routing, but we may well come back to that later. Finally, we have Linkerd running. The AI app namespace is all meshed. The Ollama namespace is all meshed. And we can use the Linkerd Viz dashboard to verify that these things are meshed. If I come over here, then I can click up on namespaces. In the AI app namespace, I have 2 of 2 things meshed. In the Ollama namespace, I have 3 of 3 things meshed. Linkerd and Linkerd Viz are always meshed. And we can also start seeing golden metrics here. They're frankly not very interesting right now because there's not much going on right now, but that's okay. All right. So in order to show using this application, we're going to start by grabbing the IP address of the AI Ingress service in the AI app namespace. That's at 192.168.107.2. And if we run this Python script, there we go. We can pass over a query. We can ask it to do prompt and say, hey, prompt the model with hello there. And it comes back and says, hello, how can I help you today? That's from the Gemma 3 270 million model, which is not a very sophisticated model. That's the least slow model, but you could already see that took a little while. We also have the Tiny Llama model loaded just for the fun of it. We're not going to use Tiny Llama for much. I just wanted to demonstrate that it is actually there. Oh, come on. One of the reasons that we didn't want to mess with GPUs was that figuring out how to give a K3D cluster running on a Macintosh access to a GPU is painful, but wow, Tiny Llama is slow. I'm going to give up in another couple of seconds here. Yeah, I'm going to give up on Tiny Llama. We're just going to stick with Gemma 3 for the rest of this because, yeah. Okay, so we're going to get some background load running so that we have some stuff to observe where it's just going to ask Gemma 3 over and over again, tell me a joke, and then dump the output off to dev null so that we don't have to look at it. And if we come back to the Viz dashboard here, then we still see that, well, we'll give it a couple of seconds here. But what we should start seeing is we should start seeing some of these things speed up. Or rather, we should see, there we go, RPS coming up as we expected. You can also see that our latencies are very, very bad. P95 at 1.6 seconds, P99 at 1.2 seconds. One of the things that really fascinates me about AI in Kubernetes is that Kubernetes was mostly designed and developed to work with stateless microservices. And AI models are kind of the opposite of that. They tend to be really a lot more like using Kubernetes to run stateful monoliths again. So it's a little bit fascinating to see all this kind of stuff. You will have noticed that, and actually, when I was showing the Linkerd Viz dashboard, everything was showing 100% success rate. So we are going to break that now. I've now told the AI app running that it should inject 503 errors 15% of the time and 429s 10% of the time, just to give us some stuff to break. And if I run this in the foreground, you can see that things are breaking. Every so often, it'll go through and give us, I think Gemma 3 always responds with the same joke. It really is a very simple model. But we can see that things are failing here. What's really interesting about this is from the client's perspective, all you know is something went wrong. You don't know where it went wrong. You don't know what the problem really is. But if we look back at the dashboard, then we have a lot more available to us. First off, we can immediately see that the AI app namespace as a whole is showing us that there are problems, and the Olama namespace is not. So that by itself is a pretty strong indication that the problem is in the AI app namespace. We can go and drill down into here. We see the call graph that we were talking about. We can see also that each of these is showing us problems roughly equally problematic. Kind of interesting, but it doesn't necessarily tell us exactly what's going on. So we can drill further in here and we can see, oh, look, if we look at our ingress, then here's our unmeshed client that's coming from outside the cluster. Prometheus is scraping this thing. But we can see that every time Prometheus tries to talk to our AI ingress, it works fine. When our unmeshed client tries to talk to it, well, we can't see the success rate for our unmeshed client, but we can see that something is going wrong with AI ingress. And we can also see things going wrong with AI app. So let's go look at AI app. Here we see something different, right? AI ingress has the problematic success rate. AI app has a problematic success rate, but Olama does not. So again, pretty strong indication that there's something going on in here. If we then want to go drill further into this, we can actually see live calls happening, courtesy of the mesh. So we can see that AI ingress, or rather AI app, gets calls from AI ingress, and it makes calls to Olama. And the calls coming from AI ingress are failing, and the calls going to Olama are not. If we want to, we can literally put these under a microscope and start digging into these things where we can see that this is from AI ingress talking to AI app. And if we look at these, then we see, actually, let me stop that so they don't go scrolling past, but we can see 503s and 200s and 429s. So we can be pretty confident that this is where these are coming from. If we expand one of these, one of the nice things about Linkerd is that you can actually go drill in and look at the actual request metadata. So we can see, yeah, look, we did a call to Olama. It worked. And we can go back up and look at one of these and see that this didn't work. We can also see that this only took us 5 milliseconds instead of a second or so. This is not a call going to a model. This is just an immediate failure. So there's really a lot of stuff we can do just by poking around and drilling in to the observability that the mesh provides to understand more about what's going on in our application. This is the basis of what we mean by looking into the black box. We want to be able to observe that things are going wrong and then start looking further into the call graph to isolate where the failures are and figure out what we can do about them. For example, if I were using an MCP server, which is a thing I also want to do at this demo, we would be able to see the calls that Olama was making to the MCP server. So we would be able to figure out, is Olama failing or is it the MCP server? This is also an area where Linkerd itself gets to know what's happening at layer 7. And so keep an eye out for interesting stuff with Linkerd learning more about how to look into these AI-specific queries. I have one more thing I wanted to show really quickly, which is that under the hood, what's happening here is that every single proxy exposes metrics in a way that Prometheus can consume. The Viz dashboard we were looking at is really just a very fancy visualizer for Prometheus data. You could go through and feed these over to -0, or you could set up a Grafana or any other observability provider you want to use. Or, you can just write little Python programs that consume it directly and then drill down and show you a application-specific view of what you want. And in this case, this little Python program is just grabbing metrics directly from the proxies for AI Ingress and AI App, and then breaking out who's talking to whom, is it working, how long is it taking, all of that stuff, because this information is readily available. So that's a whirlwind tour. There is a lot more we could talk about here, but we're just about out of time. So let me flip back and check over some of these other things here. Key takeaways. Chris, you want to pick up this last little bit?
I think Austin's on.
Austin, I think you're muted. More technical difficulties. All right. Well, just in the interest
I wonder
of
if I can. Let's see if I can unmute Austin. No, I can't unmute him.
Stuck.
Okay. Well, in
Chris
the
can
interest
type
of time,
Chris can type
yeah.
in what he was about, what he was wrapping up with in the chat for everyone to see.
Yeah. Or I can just cover it. So yeah.
You guys hear me now?
Oh, there we go. Austin's back.
Okay,
Excellent.
I'm back. Sorry about that. The interpreter here, the program shuts it off when it does both. Okay, let's.
Oh,
Okay, so I'm sorry about that. So, anyways, I know we're a little past time, but I wanted to thank Flynn for his wonderful demonstration, and hopefully, no more technical issues. Observability is important for the AI ML in production, and using the infrastructure. I want to thank everyone for coming today and listening to this and trying our our model here using this. If you can move to the next slide, we have a GitHub link that we'd like you all to use for experimentation on your own and to inject your own errors in and see what happens.
I'm actually going to skip that one for now and ask Lisa and Danielle to send out that repo in mail, because the link on the next slide is wrong, and I want to fix that first. Speaking of technical difficulties.
Okay, that's fine. That's fine. We can skip that.
Yeah.
Okay, so I know time's running out, but the last part here, I know we won't have a lot of time for question and answer, but I did want to thank everyone for coming and watching this. Flynn, do you have anything you'd like to add before we end this?
I don't believe that I do. I think we've said it all.
Okay, well, thank you guys. Thank you, everyone. Back to you.